Hello, Math 123 class. We're going to talk today about per capita and scaling things. All right, so we've mentioned previously that per capita means for one person. And so when per capita numbers are extremely small, to actually be able to write a reasonable and meaningful interpretation, we often have to scale them. And so we're going to look at the table below, and even though you can't see the whole table on my screen right now, you have a copy, and on that entire table, if we look at which country has the most licensed Starbucks location. And I see that that would be the United States. So the U.S. has the most Starbucks with 6,530 Starbucks. And which of the countries listed, Canada, United States, China, United Kingdom, or South Korea, which has the largest population? This is from 2017. Okay, so the 2017 population, the largest was China. Okay, so China had the largest population. And that population, remember this is listed in millions, so that population was 1,409.5 million people. So then actually this is over 1 billion people, 1,409,500,000. I just used the number and stuck the word million on the end like it is in the table. And so could we make a meaningful comparison between two countries regarding the popularity of Starbucks without taking the population into consideration? So for instance, can I really say that the United States it's twice as it's a little more than 2 times as popular than China, without considering, because 6,530 is a little more than twice 2,936, but not compare the populations? Not really. So we may be able to say something is more popular, but as far as it really being meaningful and being able to give a quantity with it, we cannot. Right? So we're going to need to consider the population also. Right? So we need to consider the population. And so what we're going to do is find a per capita rate to be able to compare nicely. So to do that, if we are looking then at our table here, and we're taking our Starbucks locations divided by the population in millions, okay, divided by the population in millions. And if you'd like, you could do 1,460 divided by 352 and then 5 zeros after that for 35,200,000. You would get that decimal rate, and then scientific notation, which we could use scientific notation first, and then write it as the decimal. But we are going to fill this in both ways. So whichever way you want to approach that. We've just talked about scientific notation, so we do know how to use that. So one thing to consider, since this is in millions, right, is I could just think of this number being times 10 to the 6th. But I'm going to divide by that number. So if I would divide 6,530 divide it by 325.7, what I get is 20.0. Alright, I get 20.0. So what I did was 6,530 over 325.7. And this one, now I know I didn't put the top one in scientific notation. Just work with me for a minute here. And I know the bottom isn't in perfect scientific notation. But when I divide the number parts, I get this. Actually, if I go one more place, I would round it to this. But notice we may not need to go nearly that far. But then this would be times 10 to the negative 6 because we divide it by the 10 to the 6th. So then in scientific notation, this would just be, I could say 2.01 or simply 2.0 or 2.01. But then this would be, so I rounded that one place more, and this would be 10, what would the power be now? Negative 5, because it was too big, so I add 1 to the negative 6. So everything in this column, when you're dividing by it, they're all in the millions. So there's always going to be that 10 to the 6th, which means 10 to the negative 6 since we're dividing by it. So then what I have here, 0. So here I can say this is 2.01, or actually before I round it, if I'm going to round it there, I should just, I'm sorry, but I should just leave it 2.0 because it was actually, this was actually 4.9, so we're just going to say 2.0. So 2.0, I'm resisting my urge to just start redoing the video, times 10 to the negative 5th. Alright. And so this would be then 0.1234, and then our 2, 0. So now it says Starbucks per 100,000. So you might have noticed, look at this. See how that looks the same except the times 10 to the negative 5th? That's because 10 to the 5th power is 100,000. So per 100,000 would be when there's 100,000 on the bottom of the fraction, or when it's 10 to the negative 5th. Or if I looked at my decimal, remember this is tenths, hundredths, thousandths, 10,000ths, 100,000ths. So that's why this is 2, because this is all zeros, 2 for every 100,000. So there are 2 Starbucks for every 100,000 people in the U.S. So about 1 for every 50,000 people. So pause the video and go ahead and see if you can work out the other ones on this page in the table, and then come back and I will do the same and we'll have those filled in. Alright, so you can see what I have come up with here in the table. Notice for China and South Korea, there are 5 zeros prior to another digit, 5 zeros after the decimal. And so for China, that is 2.1 times 10 to the negative 6th. Since 100,000 only takes care of negative 5, the 2.1 is 0.21. Or you might have just written 0.2. United Kingdom, it is an easy switch over because it is times 10 to the negative 5th. And then South Korea is back to like China, a smaller per capita rate. So in number 5, we are asked to use the number of Starbucks per capita for the United States in a meaningful sentence. And so I scaled that. I used the scaled up version, the per 100,000. But I guess that's really not the per capita for one person. So I wrote down there in red. So down in there in red would be the version for the per capita number, that there are 200 thousandths of a Starbucks per person in the U.S., which would be much more meaningful to say there are 2 Starbucks for every 100,000 people in the U.S., which is very much how we wrote our meaningful sentences when we were comparing things per thousand before, when we had 3 decimal places and we compared per thousand. Now we're looking at 5 decimal places and comparing per 100,000. So as number 6 says, it's really just talking about what I did there in the purple about scaling up. That small numbers in decimal form, we often need to change the scale. And so instead of just saying per capita, we're going to do it per 100,000 people and fill in the last column, which we actually already did. I kind of jumped the gun on that. Actually already have done that. Okay, so pause. I'm getting ready to go on. Pause if you need to write something down. So we'd actually already done number 6. For number 7, we're using the Starbucks per 100,000 for South Korea. So there's 6/10 or 61/100 of a Starbucks for every 100,000 people in South Korea. So in this case, would the per 100,000 be an ideal scale for every country listed in the table? And so I would say no, because some countries still do not have a whole number. Everything is still in a decimal. And I wouldn't want to round up from 0.61 all the way up to 1. That would be a pretty big jump. So what might be a better scale for China, for example? So for China, we may want to say per million instead. So per million or per 10 million. Per million be better for China. So if I were going to use the new scale per million, then I could say there are 2.1 Starbucks for every million people. So in China, I'll add in China at the beginning. In China, there are 2.1 Starbucks for every million people. I could have also done per 10 million and said in China there are 21 Starbucks for every 10 million people. I think either of those would be much easier to understand, or even just to say 2 for every million gives us much better to understand than looking at it per 100,000. And so here we're going to rank from low to high by population, by the number of Starbucks, and for Starbucks location per 100,000. So by population here, again, low to high. So Canada, South Korea, United Kingdom, then the US, then China. By Starbucks locations, South Korea has the fewest. Then United Kingdom. Then Canada. Then China. And the US. And then Starbucks location per 100,000 people. Who has the most Starbucks per capita? So actually per capita, Canada is going to be at the end of this list. So per capita, China has the fewest. Then, South Korea. Then the United Kingdom, then the US, and last, Canada. So by far, the United States has more Starbucks, but per person, which means also per 100,000, Canada has more per person, or per 100,000. All right, on our next page, we're going to look at population density. All right, population density. And so population density refers to the number of people per square area of land. In this case, square area is going to be in square miles. Sometimes you might see that as square kilometers, things like that, but per square miles in this case. So per square miles means that, hello, sorry about that, means that our area is on top, our population is on top and our area is on the bottom. All right. So please do not go left to right here. That will be incorrect. So this is going to mean that our population, our people, get divided by our area. And remember that if we could write both of them in millions, okay, so the ones with the words, if I could write both of them in millions, I could just cancel off millions. So you got a couple choices of how you enter this in your calculator. For instance, if I wanted to do populations per square mile, then for the U.S. I could do 309 with 6 zeros after it, divided by 3,717,811. Again, 6 zeros after it, 2, 3, 4, 5, 6. But what I'm going to choose to do is put them both into millions. So this one is already millions. And if I put my decimal here between the 3 and the 7, that is also millions. Now don't round it off. Wait to do your rounding at the end. So we're going to do 309 divided by the 3.717811. And I get 83, and this would be 83 people per square mile. Or maybe we could just go people per mile squared, square mile. Okay? So if I wanted to write these in millions, if I wanted to change my areas to be in millions, so what I'm doing in purple is making it in millions, I could just put a decimal here. So this decimal would be here, and here, and here, and here I would need a 0. Now this last one, I wouldn't use millions because this number is not in millions. So I would just simply do this divided by this, straight up. All right? So pause the video, see what you get. Again, you can simply trade the word million, add 6 zeros to it, 112, then 6 zeros, then do not put a decimal in your area. One or the other. Don't do both. So here, so if you want to pause and try it yourself, I'm just being a little lazy by doing ppm to the second. persons, people per square mile. Guess I don't need the 2 if I use a S. Sorry about that. If you work those out and you get something different than I had, please let me know. And then there are some questions below that we would have done in person. And then on the next page, after this one, we're going to start talking. Oh, this is not in the same order as my little booklet. All right, so maybe not on that next page. Maybe that's not where I was meaning to go. All right, then. Okay. This actually talks about proportions, and I don't feel like we've talked about proportions yet. It's going to be on the next page. So I will be introducing proportions as we go over this. But you have a better idea of what to do now with per capita. Thanks.